All right, let's talk about the absolute heart of Java programming, methods. I mean, these are the Lego bricks, the very things you'll use to build pretty much everything, from a simple script all the way up to a massive, complex application.
You know that feeling, right? When you're scrolling and scrolling through one giant file, or you realize you've copy-pasted the same 10 lines of code for the 5th time. It's messy, it's a headache, but there's a much, much better way.
And that better way is the method. Think of it like this. It's a specialized tool. You wouldn't rebuild a hammer every single time you needed to hit a nail, right? Would you? Of course not. You just grab the hammer. That's what a method is. It's a named chunk of code that does one specific thing, and you can just call on it whenever you need it. This is how we build clean, smart, and really powerful programs. So here's the game plan for this explainer. We're going to start with the basics, how to build these reusable blocks. Then we'll dive into the really juicy stuff, how you pass data into them. We'll solve that whole pass-by-value puzzle. After that, we'll see how to get results back out. And we'll wrap up with some super handy special tools called static methods. Sound good? Let's get to it.
First things first, let's look at the anatomy of a method. What does one of these things actually look like?
This is the perfect blueprint. Let's just break it down using this selection sort example. First up, public. That's the access modifier. It basically means anyone can see and use this method. The static keyword is optional, and we'll circle back to that one, I promise. Next is the return type, void. This tells Java what kind of data the method gives back. In this case, void means it returns, well, nothing. Its job is just to do something. Then you have the name, selection sort. You want a good, descriptive verb. And finally, inside the parentheses, you've got the parameters. This is the information the method needs to do its job. Here, it needs a list of doubles.
So with all these methods calling other methods, how does Java not get totally lost? It uses something called the call stack. The easiest way to picture it is like a stack of plates. Your program starts, and main gets the first plate on the stack. Then, main calls another method, say max. Boom, a new plate from max gets put right on top. Max does its thing, finishes up, and its plate is taken off the top. And where are we? Right back in the main method, which is now the top plate again. It's a beautifully simple system that lets your program jump around without ever losing its place.
Okay, so we can build a method, but a tool isn't much good if you can't give it something to work on, right? This is where passing data comes in.
And this is a really important question. I mean, this concept is the source of so many headaches for new developers. If you can nail this, you'll avoid a ton of common bugs down the road. The whole secret is understanding that Java treats two kinds of data differently. On one hand, you have your primitives. These are the simple things like an int, a double, a boolean. On the other hand, you have objects, which are more complex things. Now, when you pass a primitive, Java passes a copy of the value. But when you pass an object, it passes a copy of the reference. Think of it as the object's address in memory.
Let's stick with primitives for a second. Imagine you have a variable, x, and it's equal to 5. When you pass x to a method, the method gets its very own, separate copy of the number 5. The method can go nuts with its copy. It can change it to 99, it can do whatever. Your original x, it's still sitting there, safe and sound, holding the value 5, it's completely unchanged.
But with objects, as this quote says, the situation changes dramatically. You see, it's the reference that gets passed, not the object itself. So the method doesn't get the object, it gets the location of the original object. It knows where it lives. This brings me to my favorite analogy for this, the treasure map. Think of your object as a big treasure chest. When you pass that object to a method, you are not giving the method the treasure chest. You're giving it a photocopy of the treasure map. Now, the method can take its copy of the map, follow it to your original treasure chests, and mess with the contents. It can add gold, it can take jewels out, but here's the key. It cannot change your original map to point to a totally different treasure island. Your map is safe. The method only has a copy.
Okay, so we've successfully passed data into our methods. But methods do work for us. How do we get the results of that work back out?
Well, that's the whole job of the return type. A method can send back a simple int or double. It can send back a complex object, like a string, or a custom player object. Or, like we saw before, it can have a return type of void,
which is basically a promise that it isn't sending anything back at all. And for you advanced folks, there's a cool trick called covariant returns, which lets a method promise to return a more specific kind of object than its parent did, which is pretty slick.
All right, let's talk about a special kind of method, one that doesn't need an object or a treasure map at all, because it belongs to everyone.
We're talking about static methods. A static member belongs to the class itself, not to any one single object. This means you don't need to create an instance with the new keyword to use it. You just call it directly on the class name. This makes them absolutely perfect for creating utility methods. Think of them as the shared power tools in the workshop, available for any job, anytime.
The perfect example is Java's built-in math class. You've probably used it. You never ever write new math at OHO. You just say math.floorDiv or math.addExact when you need a calculation done. It's a whole library of tools just sitting there, ready to go. And speaking of that, Java comes packed with an amazing built-in toolkit, and a lot of it is powered by these incredibly useful static methods.
Just look at some of these from the math class. AddExact and IncrementExact are amazing because they act like a safety net. If you add two giant numbers and the result overflows, a normal plus sign might just give you a weird negative number, a bug that's super hard to find. But AddExact will throw an error, telling you exactly what went wrong. And FloorDiv handles negative number division properly, which fixes another classic, subtle source of bugs.
Now, not every utility is purely static. The random class, for instance, you do have to create an object first using new. But once you've got it, you can just ask it for a random number whenever you want. It's another powerful tool for games, for testing, for pretty much anything that needs a little unpredictability.
So, after all that, the call stack, primitives, objects, treasure maps, what's the one thing, the single most important rule to remember? It's this. Java only has one way of passing things to methods, just one. It's always pass by value. It's just that sometimes the value it's copying is a number, and sometimes the value it's copying is the address on a treasure map.
So there you have it. We've seen how methods let you organize your code, how you can pass data around, and how you can tap into this huge toolkit that's already built for you. They really are the foundation of everything you're going to build. So, I guess the only question left is, now that you've got the building blocks, what are you going to create first?